So the first thing we do in this is we are going to solve differential equations in a little bit different form than what you're used to. So far, you've only had like a derivative of y and some function of x, and you've taken the antiderivative. And what you'll notice here is you have the derivative of y equals 2x over y. And so we have this little process here. And so when you have something like this, you do want to get your like variables together. So you would want to multiply that y over. But you still have this y prime to deal with. And so you are going to integrate with respect to x, both sides, right? And so if you were to think about u substitution here, if my u is y, then my du with respect to x is going to be the derivative of y dy dx, or just dx, right? And so this is actually taken care of in the dy piece of it. And so you have this integration of y dy, because that's taken care of here, equal to the integration of 2x dx. And so when you integrate y, you do just like you would for integrating x. You're going to add 1 to the exponent and divide by my new exponent. So it's going to be y squared divided by 2. Over here, we're going to have 2x squared, right, divided by 2 and plus c. And of course, that's going to cancel. So then I have my 1/2 y squared equals my x squared plus c. You can get rid of that 1/2 if you want to. If you don't, it's fine, but they're just going to put it in a standard type form. So y squared minus x squared equals c. And in the book, they simplified one step more by multiplying everything by 2. Now, 2c is just a constant. So c just represents a constant, not really a variable, so you can just leave that as a c. You don't have to put 2c there. And so when you're solving a differential equation, this is almost like an implicit differential, just like when we did implicit derivatives, right? So we're thinking about the implicit form of it. Now, the application here is when you start moving into growth decay models. And so growth and decay is something that you're used to with interest, right? Which we did a little bit before the break, because we're doing, natural logs, which leads to your interest equations. Rate of change. So the rate of change is proportional to y, which is where we have this exponential growth, which should look just like this one. So those should look the same, because they are, right? You have exponential growth. This one specifically is when you're talking about money, right? Principal, etc. This is when there's typically used when it's anything else. C is your initial value. K is how you're proportional to the constant. Exponential growth occurs when k is bigger than 0. Exponential decay occurs when k is less than 0. All right, and so this should seem very much familiar, like we did in pre-cal. So the first one, they give us the rate of change y is proportional to y when t equals 0 and y equals 2. When t is 2, y is 4. What's the value of y when t equals 3? Now, before this, in pre-cal world, we'd have set up ratios and solved, right? But they want us to actually set up a growth model. All right, so if they specifically say I want a growth model, then you're actually going to need to figure out what k is to go forward. And so you're going to use the same formula that they had. You're going to say y equals c e to the kt. And so we're going to just plug in what we have. Well, if t is 0 when y is 2, 2 is our initial. Well, we already said c was our initial. So even if you plugged that in and said 2 equals c e to the k times 0, you're going to see that c equals 2. So anytime they give you a time of 0, they've given you your initial or your c. So we can already start by saying, okay, they've given us our initial of 2. We already know that. All right. And so then they've given us another set of information, 2 and 4. So we can just plug it in. 4 equals 2 e to the 4 times k. Well, I wrote that backwards. 2 times k. Okay. To solve it, we're going to use our logarithmic information. Divide by 2. 2 equals e to the 2k. Natural log of both sides to get rid of that e. So we have ln of 2 equals e to the, well, actually e is going to cancel, so we have 2k. Divide by 2, so you get ln of 2 divided by 2 equals k. When you plug that in, you get your k, which is what we're solving for. And so if they want you to set up an initial equation here, you're going to say, well, my c, I know they gave it to me, and now I also know my k. And now I can solve for any time. They want me to solve for 3, well, I'm just going to plug in 3. Y equals 2 e to my k times my 3. And then you just solve, right? So we have solved for our growth and decay, and we've solved for a specific time. All right, it says, suppose that 10 grams of plutonium isotope Pu-239 was released in the Chernobyl nuclear accident. How long will it take for the 10 grams to decay to 1 gram? They've given us a half-life for plutonium. So we have a half-life of 24,360 for plutonium, for this particular isotope. They actually told us the initial. How long will it take for 10 grams? They've given us my initial amount. So if I'm using my y equals c e to the kt, they've given me c. I actually already know a specific time. In 24,360 years, that 10 grams will be at half of 10 grams, which is 5. So I know that it will be 5 when my 10 grams is multiplied by this guy, right? That's my half-life. So for 10 grams, in 24,000 years, it'll be at 5 grams. That's what it means by half-life. And so I can actually solve this. By the way, half-life will always look like that when you do it, using the same exactly what I did before. So natural log of that is going to be the 24,360k. Divide both sides by that. And you are going to get a negative number here, which, by the way, when you're using your logic skills to do these problems, it makes sense that your k is negative. Well, why? Because we're talking about decay. And so if you get a positive, k on a decay problem, you probably did something wrong. So it's a good thing to look for, right? So we have my k. So I now know my problem here is going to look like this. 10 e to the, and I'm just going to do that because I don't want to write him again, t. And so now we say, well, what is the problem asking us? How long will it take for it to be 1 gram? Which means I'm solving for my t. So I am wanting it to be 1. I am solving for my t here. So I'm going to do the same thing. Well, it helps to write. The natural log of this is going to be equal to that guy times t. Natural log of this divided by this guy will equal how long it will take. And when you do that, by the way, for 10 grams to go to 1 gram is 80,923 years. So obviously growth, we're looking for a positive k on this one. So easy enough. Suppose there's a population of fruit flies increasing according to the law of exponential growth. There were 100 flies after the second day of the experiment. 300 flies after the 4th day approximate how many flies were in the original population. In this case, they did not give us the initial amount. They gave us after 2 days. Anyway, so our amount that we do have is 100. We do not know C at this time. We would say E to the 2K here. That's after 2 days. If we were solving for for C, then we would divide both sides by this. So we would have 100 over E to the 2K equals C. Or you could write it like this, 100 E to the negative 2K, right? Because negative just puts it in the denominator. And so if we use this as our C, we can actually go on to the next group of information that we have. We have 300 equals, and instead of C, we're going to write this guy. And then E to the 4K, right? And so we can actually combine my E's because it's like bases. Make sense? So I can say 300 equals 100 and then add my like bases. Negative 2K and positive 4K is just going to be 2K. So basically, if you think about this, I could use an initial amount of 100, but not with 0 and 2. It would have to be 2 to 4. So I could use an initial amount of 100, but I then could not use a 4 for my 300 because it was only 2 days after my first one. So if you are given 2 amounts and it's not at time 0, you can use your first amount, but then your second amount, your time is going to have to be starting from your first amount. That's why it went from 4 to 2. Because 100 was after 2 days, 300 was 2 more days from that. And so now it looks like 100 is my initial, and the 300 is at 2 days. Technically, it's 2 days after the 100. Does that make sense? And this is why. So now you can very easily solve for your K. Divide by the 100 there and take your natural log. So you have your natural log of 3 equals your 2K. When you take this and divide, you're going to get a K of 0.5493. We are looking for a positive because of my growth. Approximately how many flies were in the original population? Okay, so original population then is we want to know then what happens to figure out my initial. And so if I want to say how many did they originally have, I'm going to actually go back to this guy and figure out what my actual C is, if that makes sense. So I'm going to say, well, I know I had 100 after 2 days. I now know what my K is. So now I can actually use this to figure out what my initial was. And so I would just say the 100 divided by this E to the 2 times my K. And I'll get approximately 33 fruit flies based on the fact that I rounded. It could be, somewhere around there. Declining sales, positive or negative K? Yeah. So 4 months after stopping advertising, a manufacturer company notices that its sales have dropped from 100,000 units per month to 80,000 units per month. If the sales follow an exponential pattern of decline, what will they be after another 2 months? They gave me the initial, right? So I don't have to worry about finding my initial. So I know that that is 80,000 from an initial of 100,000 after 4 months. There we go. I was trying to find my, right. And so I can solve, of course, the natural log of the 0.8 if I divide over equals 4K. If I take that divided by 4, I'm going to K of negative 0.0558, which is what I'm looking for. After another 2 months, pay attention to your wording here, all right? So pay attention to your wording. So I would say, if the sales, what will they be? I'm looking for this guy here. I'm looking for my Y. I know my initial is 100,000. E to the 2 more months. Yeah, so we're going to say 6K there. And our K, of course, we already know. 0.558. So you want to make sure you're reading your word problems well on these, especially like in a standardized test or something. They're going to throw a question at you and you're going to have to make sure you know what you're solving for and what information you have. So if you need to solve for k, like if it's asking you for the actual equation, then you would want to solve for k. If not, you can just plug in that little natural log of 2.5 over 3 and get your answer. If all they're asking you for is what's the value of y when x is 6, then you can just go straight to the solving. But if they want you to actually solve the equation, you'll want to calculate your k.